Yeah, so now in continuation in height and distances, let's see this question. Question number 8. As observed from the top of a 100-meter high lighthouse from sea level. Okay. The angle of depression of the two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the ships. Okay. So let's see what can be the figure we can draw here, right? So suppose this is the ground level, right? This one, okay, and not ground level, sea level, right? So this is the sea level. Now, from the sea level, you can see AB here. AB is the lighthouse, okay? So AB is lighthouse, right? Which is 100-meter high, okay? So what is the length? What is the height of the lighthouse? This is 100 meters from the sea level, okay? So this is 100 meters. We have marked here, right? Now the angle of depression of the two ships, suppose the two ships are at position D and C, okay, right? Angle of depression of the two ships are 30 degree and 45 degree, and one ship is exactly behind the other. So we have taken here that C is exactly behind the D, right? Okay, on the one line, okay. And the angle of depression here from the top of the lighthouse, that is point B, is 30 degree and 45 degree, right? So this is 30 degree and this is 45. Or you can say here, angle of depression 30 degree and 45 degree. Getting it? Right. So these are the angle of depression. Now, so angle ACB, okay. Angle ACB, since this is 30 degree, so we have taken this also is 30 degree, since this is 45 degree and this is also 45 degree, right? Why? Because we have drawn a line here, BE, right, which is parallel to this AC, right? Okay. These are the angle of depression, 30 degree and 45 degree, right? And taking these are the transversal, right? We have drawn the alternate angles here, which are equal, right? So this is 45, so this is also 45. This is 30, so this is also 30. Now, what we can do is, now consider the triangle ADB, right? So first write down ACB is 30 degree, right? And angle ADB is 45 degree. Now what we have to find? We have to find the distance between the ships, right? That means if C and D are the two points where the ships are there, we have to find the distance between them, and suppose it is X meters. Okay. So suppose this is X meters. So we have to find CD here. CD is X meters. Okay. Now, in a right angle triangle DAB, this is a right angle triangle. In right angle triangle DAB, right? What we have? Cot theta. Cot theta. What is cot theta? Base upon perpendicular, right? Okay. Base is CA, right? Okay. Sorry, not this one. In DAB, right, we will take tan theta first. Tan theta is equals to base upon perpendicular. Base is AD and perpendicular is AB. Okay. AD and AB, right, in triangle DAB, right? So now write down the values. Theta is 45 degree. Okay. AD, what is AD? What is AD? Tell me. We have to find it. We don't know AD, right? So write down here. AB is 100 meters, right? So this is 1. 1 is equals to AD upon 100. So AD will also be 100. So write down here. AD is 100 meters, right? So we have marked here that this is 100 meters, right? Now, consider the triangle CAB, right? In triangle CAB, cot 30 degree, or you can say cot theta, is base upon perpendicular, right? Base is CA, right? Okay, base is CA and perpendicular is AB. Okay, so write down CA upon AB, right? So cot 30 degree, theta is 30 degree for this angle, for this triangle, right? And this is equal to, now what is CA? If this is 100 and this is X, then this CA will be X plus 100, right? CA will be equal to X plus 100 meters. Okay, so write down CA is equal to X plus 100. upon AB. AB is 100, right? Length of the lighthouse, height of the lighthouse is 100. Now, what is cot 30 degree? What is the value of cot 30 degree? That is root 3. Root 3 is equal to x plus 100 upon 100. Now we can solve this equation. So x plus 100 is equals to 100 root 3, right? So x is equal to 100 root 3 minus 100. Getting it? Okay. So x will be equal to 100. You can take common. So this will become root 3 minus 1. Okay. That is. Now put the value of root 3. Root 3 is 1.732 minus 1. That's it. 100 into 0.732. Right? Then this is equal to, the value of x will be equal to 73.2, approximately this much meters. Okay, so in this way we have got the distance between the two ships, right? So now you can write down, hence the distance between the two ships is 73 meters, 73.2 meters. And this is the answer. Is that clear? So this time what is given? Angle of depression is given, right? Okay. So angle of depression. Now we can take the alternate interior angles, right? Okay, in this way we can use the trigonometric ratios in the right angle triangle, and then we can find the distance between the two ships. Is that clear? So now in this another question, question number 9. Two ships are approaching a lighthouse from opposite directions, and the angle of depression of the two ships from the top of a lighthouse is 30 degree and 45 degree. Okay. If the distance between the two ships is 100 meters, then you have to find the height of the lighthouse. Okay. So we can draw this in a diagram, right? Suppose AB is the lighthouse, right? Okay. So let AB is the lighthouse. Now for this AB, you have to find the height. That means suppose it is h. So AB is equal to h meters. Okay. Right. Now C and D, these are the two positions. These are the position of the two ships, right? Okay. This is a ship, and this is also a ship, right? Okay. Since both are approaching towards the lighthouse, that means they are in the opposite direction of the lighthouse, and that's the reason we have taken these points in the opposite directions of the lighthouse AB, right? Now, angle ACB. What will be the angle of ACB? Because here it is given that angle of depressions are 30 degree and 45 degree, right? So suppose if this is 30 degree, then this will also be 30 degree, right? Okay, alternate interior angles. And 45 degree, then this will also be 45 degree on alternate interior angles. So ACB is 30 degree and angle ADB is 45 degree, right? Okay, and AB we have taken h meters. Now suppose CA, the distance of ship C from lighthouse, the foot of the lighthouse is suppose x, then this will be equal to 100 minus x. Why? Because the distance between the two ships is given here 100 meters, right? This is already given here. Distance between the two ships is 100 meters, right? So CD is equal to 100 meters, right? CA is suppose x. Therefore, AD will be equal to 100 minus x meters. Getting that? Okay. Now, in the right angle triangle BAD, right? You can see there are two right angle triangles. Now consider the triangle BAD, this triangle. Okay. Right angled at A. Okay. Now, in this triangle, cot 45 degree, right? This is equal to theta is 45. Cot 45 degree is AD upon AB, right? AD upon AB, base upon perpendicular is cot theta. So write down AD upon AB, right? Now, what is the value of cot 45 degree? That is 1. Okay. Cot 45 degree is 1. 1 is equals to AD upon AB. Now, what is your AD? AD is 100 minus x, right? And AB is h, right? Okay. So write down 100 minus x upon h, right? So from here, we can say that h is equals to 100 minus x, right? Okay. Is that clear? Or x is equal to 100 minus h, right? Is that clear? Getting it? So this is suppose equation number 1. Now, from triangle, another right angle triangle, BAC. Now look at this, another triangle, BAC, right? Now, this time cot 30 degree, this will be equal to AC base upon AB perpendicular, right? Okay, so write down cot 30 degree is AC upon AB base upon perpendicular. Getting it? Now, what is cot 30 degree? Cot 30 degree value is root 3, right? Cot 30 degree is root 3. Now, what is AC? AC is x and AB is h, right? So it will become x upon h. Is that clear? Right? That means what? X is equal to h root 3, right? And this is equation number 2. Now from 1 and 2, in both, from both the equations, we are having the value of x, right? So we can equate them, right? From 1 and 2, right? So we can equate them, equating the values of x, right? What we have, that 100 minus h is equals to h root 3, okay? Or 100 is equals to h root 3 plus h, okay? Now taking h common, you will get root 3 plus 1, okay? Now, by getting it, now again, so you can say h will be equal to 100 upon root 3 plus 1. We can write like this, okay? You can rationalize this. You can write down 100 upon root 3 plus 1. Now you can rationalize it by multiplying root 3 minus 1 in both numerator and denominators, right? So this way, this is equal to 100 root 3 minus 1. Now upon this will be root 3 square minus 1 square, right? And this will be equal to 100 root 3 minus 1. Root 3 square is 3 minus 1, that is 2, okay? So now you can cut this 100 root 3 minus 1 upon 2. So this will cut, this is 50, right? So these are all values of h, okay? Everybody getting till here? Yes or no? Now,
Yes,
to
ma'am.
find the final value of h, right, we will put the value of root 3. Root 3 is 1.732, okay? So 50 into 0.732, right? Now multiply. So this will be equal to 36.6 meters, right? So in this way, we have got the value of the lighthouse, the height of the lighthouse, that is h. So you can write down, hence the height of the lighthouse is 36.6 meters, and this is your answer. Okay, so I hope now you're getting it, right? So we have got two equations, right, in x and h, and by equating them, we can finally got the value of h. Is that clear? Now look at this question number 10. From a window h meters high above the ground of a house in a street. Okay, so in a street there is a house, and in the house at h meters from the ground, above the ground, there is a window. Okay, now the angles of elevation and depression of the top and foot of another house on the opposite side of the street. Okay, so the first house is on the one side and another house is now on the opposite side of the street, and the angle of elevation and depression from that window, okay, of the top and foot of that another house which is on the opposite side of the street, are theta and phi respectively. Now we have to show that height of the opposite house is h1 plus tan theta cot phi. Okay, so first we have drawn this, right? So you can see here we have taken AB as the house, right, the first house, and at B point, right here, there is a window. Okay, so this is the height of the window, and this is h meters from the ground. Okay, so this is the ground level. Okay, now on the opposite side of the street, there is another house. Okay, and this is the top of the house. Okay, and this is the bottom of the house, another house, right? Is it clear? Now, the angle of elevation and depression, right? So it is given here, angle of elevation and depression is theta and phi respectively, right? So this is theta and depression is phi, right? So we can mark this here. So this is theta and this is phi. Angle of depression is phi and angle of elevation is theta. Now what we have to find? We have to prove that the height of the opposite house is h1 plus tan theta cot phi. Okay, now this is write down. Let AB be the house with window at B. Okay, and CD be the another house. Okay, now AB is h meters. This is already given in the questions. AB is h meter, right? Now here what we have drawn? We have drawn BE which is parallel to AC, right? So this line which you can see here, this is BE which is parallel to AC, okay? Right? And angle EBD is theta, the angle of elevation, and angle ACB, okay? Angle ACB is equals to phi, okay? And this is also equal to E, is also equal to EBC, right? So this and this are equal because BC is the transversal between the two parallel lines, BE and AC. So these are alternate integral angles which are equal, okay? So this is equal to phi and this is angle EBC as well, okay? Now, let's assume that the height of the another house is suppose capital H meters, right? So height of this CD, the other house on the opposite side of the street is suppose H meters, right? Okay. So in this way, EC will become, this is H because this is a parallel to this AB and EC, right? So this will be equal to AB, okay? And this will be H minus H, right? So write down CE is AB is equal to H and ED is equals to H minus H meters. Okay, now from right angle triangle ACB. Now look at the triangle ACB here. ACB, this one, right? Now cot phi is base upon perpendicular, right? Cot phi is base upon perpendicular, means AC upon AB, right? So write down cot phi is equals to AC upon AB. Getting it? Okay. AC upon AB. What is AB? AB is H, right? H meters, right? So from here we can say that AC is equal to H cot phi meters, right? Okay. So we have got value of AC. Now from another right angle triangle BED, from right angle triangle BED, this one BED, right? In this we have tan theta. Tan theta is perpendicular upon base, right? Means DE upon BE. DE is H minus H and BE, we can find BE in terms of this, right? Okay, so write down tan theta is perpendicular, that is DE upon base, that is BE, right? Now DE is H minus H, okay? And what is BE? What is BE? BE is equal to, look at here, BE is equal to AC, right? BE is equal to AC, right? So we can equate them. And what is your AC? AC is H cos phi, right? Okay. So you can write down h cos phi. Why? Since BE is equal to AC is equals to h cos phi. Getting it? Okay, so this is equal to tan theta. Okay, so you can say that h minus h is equals to h tan theta cos phi, right? Okay, now h you can take small h to other side, so it will become h tan theta cos phi plus h. Now take h common, so it will become h 1 plus tan theta cos phi. And what is this? This is h, which is the height of the opposite house, that is CD. Okay, so we have proved that height of the opposite house is h into 1 plus tan theta cos phi, right? So this only we have to prove here, that height of the opposite house is h1 plus tan theta cos phi meters. Okay, so this we have. Okay, therefore the height of the opposite house is h1 plus tan theta cos phi. So I hope you're getting this now.